6.1 Roots and Radical Expressions. We are going to identify parts of a radical expression. We're going to be able to just simplify radical expressions with variables, and then we're going to find the real roots. So we're going to go into radicals pretty intense in this chapter. All right, so the nth root of a number is what we're looking for. All right, so looking over here, breaking down what the parts of a radical expression are. The n right here, that is for your index. And we'll refer to that as n. So the nth root means it could be any number right there. The symbol itself, the square root symbol or the radical symbol, is called the radical sign, and anything underneath that radical sign is called the radicand. It's not super important that you know all that terminology. You really need to know and understand the index. But the radicand is just whatever's underneath the radical sign. If there's not a number in the index area, it's understood to be a 2, or it's the square root of. So if there's no number right here, it's considered to be the square root of. That's the smallest root you'll be working with. The index tells us how many times you need to multiply the same number or expression. So in other words, if we were taking the square root of, let's see, get a different color where you can see it, the square root of 36. What that means is how many times can you multiply a number, the same number, to get 36? Well, you can multiply 6 times 6, and that is the square root. 6 is the square root of 36. Alright, if the index, and we'll refer, like I said, to the index is even, then there will be 2 real roots. But if the n is odd, there will only be 1 real root. Okay, we will be working with real numbers and very soon non-real numbers. Alright, so to take the roots of variables, because now we're going to have variables included with the rest of our numbers, we're going to divide the exponent. Remember, the exponent is this little number that's hanging up there in the air. Divide the exponent by the index. So for in this case, the cube root of a12 is going to be the same thing as a to the 12 divided by 3 power, which means that's going to make a to the 4th. Okay, because if you split up your a's, had 12 of them, which I have split up 12 of these, and you group them in groups of 3, whatever the index was. So I group it in groups of 3. There's 1 group, there's 2 groups, 3 groups, and 4 groups. Whoops. As you can tell, that would mean a to the 4th power. There are 4 groups of 3. That's what it means. Now, to use a calculator to find the roots of the numbers depends on what it is. If it's a square root, you're going to hit second and then your x squared button, and right above that x squared button is going to be the square root button, and you put in whatever's underneath the radical sign and then hit enter. Alright, so let me show you with my calculator what I'm talking about. So you're going to go to second, make sure my calculator is on. You go to second, and then you go to the x squared button. You see this radical sign? It's in yellow. Any of these yellow numbers, you have to push the yellow button to get. So you push that, and then if we wanted to find 49, we hit enter, and that'll tell us 7. Okay? So that'll take care of the square roots. Get this out of the way. Alright, so if we want to talk about cube roots, cube meaning 3, you hit math 4, and then whatever's in radical, under the radical sign, and then hit enter. For example, if I wanted to know, move this up a little bit, the cube root of 64, I would go to math, and number 4 says the cube root of something. So math 4, and then hit 64 and hit enter. Now most of the time, because we're not doing anything else, we can just hit enter, but if we have anything else we need to put together with this radical, you're going to need to close it off. So maybe I should just go ahead and get you in the habit of closing it off every time. Hit enter, and that'll give you the cube root of 64 being 4. Okay. Now if we have any other root, like the 4th root, the 5th root, 6th root, any other root, you're going to put in the index, whatever it is. If it's the 5th root, you would put 5. If it was the 6th root, you put a 6. You do that first, and then you do math 5, and then put whatever's under the radical sign, and then hit enter. For example, let's say we have the 5th root, and then you're going to hit math, and you go to number 5. See where it has the little X? That's for any root beyond the cube root. So we hit math 5, and let's think of something. Let's see. Let's think of 164. Let's see if that works. Close it off and hit enter. Nope. Should have known. Alright, let me try that again. 5, math 5, and let me get one that's going to work. Hang on just a second. Oh, that'll work. Type in 32. Close it off. And hit enter. What in the world? 5th root of 32 should maybe. Oh, okay. Oh, interesting. Look what it's doing when it's doing like anything above the 3rd root. It's not putting that extra parenthesis in, so that's why it's giving me an error. Alright, so if I hit second enter, go back, it's not going to give me that extra parenthesis, so I need to not put one on the end. However, you be really careful with those when you're working with those higher numbers and higher index. There you go. Alright, so anything above on a TI-83, anything above the cube root, it will not give you that parenthesis that goes right there. So don't add one to the end. You just have to watch that, unless you put one before it, because what's going to happen, if it only has one parenthesis still the set, it's going to give you that error message that I was getting. Alright, so just watch that. If you're going to do the parenthesis thing, that's fine. Make sure you put one at the beginning on these, okay? Alright, so good to know. I'm glad I saw that. Alright, so those are your instructions on how to put it in your calculator. Let's go to the next slide. Alright, so you need to become very familiar with perfect squares and perfect cubes. The squares, of course, are 1, 4, 9, 16, 25, 36, 49, and on and on and on. You need to know those, and if you don't know them, you can always, write on the side of the paper, write 1 squared, 2 squared, blah, blah, and write them all down. Okay, you'll also need to know the cubes very well. That would be 1 to the 3rd power, 2 to the 3rd power, 3 to the 3rd power, and so on and so on and so on. That'll give you these, okay? You can use your calculator and calculate these out, but you really should get familiar with these numbers, because these numbers you'll see often, especially 64. They like to use that because if you're not paying attention, it could be a square, a perfect square, and it could also be a perfect cube. So be watching that. Alright, radical expressions are in their simplest form when. n is as small as possible. Okay, the index is small as possible. The radicand, or the number in the radical, contains no factors that can be taken out of the radical. No nth roots can be taken out of any of the factors or the expressions. All right, so the radicand cannot contain any fractions. Okay, so when we're working with this, we have to get rid of the fractions, and there cannot be any radicals in the denominator. We'll learn how to do that too. Examples: the cube root of a to the 6th power, b to the 9th power. All you remember, you're just going to divide out your exponents to whatever your index is. So just remember, you're going to divide exponent by the index. Okay, so my index is 3 and my exponent is 6. So I'll say 6 divided by 3, which gives me your 2 right here. 9 divided by 3 will give me my 3 right there. So you just divide your exponent by the index, and that'll give you your simplified variable. All right, this one, square root of 500, a to the 5th power b, simplifies to, and if you need to see it broken down, the square root of 100 times the square root of 5ab. You'll get a lot of practice with this. You'll start seeing some of these patterns. They use these a lot. Well, the square root of 100 is 10. And then a, that should have had, I should have wrote right here, a5. All right, so that's going to be 5 divided by 2. 5 divided by 2 is going to give you 2 and 1 left over. So that's why A2 comes out. You have 1 left over. And the B, there's B1 divided by 2 is just going to leave you with a B on the inside. It has to have a partner to go out. Okay, it comes out in this case because the index is 2. It comes out in groups of 2. So that's why this one is left over, so that what's left inside will give you 5ab. And we're going to practice these a lot, so don't worry if we don't get it the first time. And then the square root of 9b10. Square root of 9 is 3. And then 10 divided by 2, 10 divided by 2 will give you your b5. Okay? Now, you have to use a plus minus symbol, which your calculator does not have, when n is even and the radical sign is completely eliminated. So, when you do a problem like this, now we've always said square root of 100 was 10. Technically, it's really plus or minus 10 because 10 squared is 100, but so is negative 10 squared. That's why it has to be plus or minus. You will see these, and you will need to have plus or minus in front of your answers because they won't be quite right unless you do. You'll also notice those on any of your standardized tests, they'll have plus or minus in front of it. So anytime the index right here is even, that means 2, 4, 6, 8, and the radical sign is completely eliminated, that means it could be a positive answer or a negative answer. Because, as you see, anytime you square, whether it's positive or negative, you're still going to get a positive number. Now, if there is a negative underneath here, that makes a huge, huge difference, and that changes everything. Right now, we're not going to work with those. We're just working with the positive ones right now. All right, next problem. All right, so for example, square root of 25z8 is equal to the square root of 25 times the square root of z8. You can break it down like that if that's what you need to do to see the parts. Well, we know the square root of 25 is 5. And then you just take your 8, your z8, and you're going to do 8 divided by, and our index was 2. That gives us 4. And that's the reason why this is a plus or minus, because it's an even index, 5z4. Okay? Next example is the square root of 250 m3 n 10, and that will break down to the square root of 25 times the square root of 10, m3 n 10. Okay, if you need to split it up, you can. And then you will do the square root of 25, which makes 5. All right, m3 divided by 2 gives you 1.5, so we take out 1, leave 1 in. He doesn't have a pair, he has to stay in. 10 divided by 5, which is 2. Excuse me. 10 divided by 2, which is 5. That's why this n is outside of n5. There's no n's left over. If they're completely eliminated and it's an even answer, it comes out. Okay? Now, if you need to do trees, you can do 250 and break this down into trees. 2 and 125. That breaks down to 5 and 25. That breaks down to 5 and 5. And once you have all prime numbers, you take out your groups. This group will come out, and the prime numbers left over you multiply together, and they stay inside. Okay? You can do your letters, you write out all your letters. You can circle them like M, M, M for M3 and take out a pair. That would come out here, and one left over stays inside. And then same with the N's. If you had 10 of them, you would circle all the pairs and you would end up with N5 outside. Okay? You can do it this way too. We will practice both in class. Whichever way works for you, do it, as long as you're getting them consistently right. You can use your calculator to simplify. If you have decimals in your radical, you're allowed to have decimals in your answers. Okay? But most of the time, you will not have decimals in your answers, and you won't have decimals in the radicals. We'll mostly be working with whole numbers that need to be simplified as far as can be. So just know, unless there's a decimal there, you won't have decimals ever in this unit. Okay? All right, so putting it in your calculator will not help you because you're going to get a decimal. So you're going to have to learn how to break these down correctly. What are the real cube roots of 0.008, negative 1,000, and 1 over 27? Well, breaking this down, the cube roots, what they're asking you about, cube roots. The cube root of 0.008 is 0.2 because 0.2 to the third power makes 0.8. So you can go back and check your work when you're finished and see if it works. Now, cube root of negative 1,000 is negative 10 because of the odd exponent, right? The odd index right there. We can have negative answers. However, if it was an even exponent, even index, we cannot have negatives underneath there right now. We will very shortly. They're non-real numbers. But right now, if you have an even index, you cannot take out a negative number, okay? But because this is odd, we can do that because negative 10 to the third power, which would be negative 10 times a negative 10, times a negative 10, that will make a negative answer. But oops, not that many, don't look at that. But if you were trying to do that and say you had the square root of negative 100, you cannot do negative 10 times a negative 10 and get a negative answer. That does not work. You would get a positive answer, which is not what we have here. So that's why this does not work for an even index. Only if it's odd. And so this one, the last example, is the cube root of 1 over 27. You take the cube root of 1, which is 1, and the cube root of 27, which is 3. You can break these apart. You actually can write these like this if you see that. You should be real familiar with breaking them apart if you need to make it easier to look at. Okay, the cube root of 1 is 1. The cube root of 27 is 3. Okay, and 1/3 to the third power will make 1/27. But you can take anything that's in a fraction form like this and split it up so that it's a radical over a radical. We're going to learn how to fix those too. But just know that you can switch them back and forth so that it's easier for you to understand. Okay? Alright, so we will be practicing in class lots of these because it's very important that we know how to simplify these. And if you have any questions, come see me and I'll see you in class.